Hi everyone. I hope that you are all doing well and I'm also doing well. And my name is Babili Sarath Kumar and I work as a security software developer for IoT devices. And and our project we are working on building secure building blocks for IoT and automotive products. Today I'm going to show you a demo, like simple demo. And the main focus of the demo is how to use Rust. Like as a security software developer for IoT, basically we're using Rust programming language for developing the secure building blocks, and it is a part of it will adds advantages securing the products whatever we're developing will make sure that there is no memory related bugs, and also the security vulnerabilities we are trying to reduce as much as possible using Rust and our uh, expertise in that field. And today I'm going to show you a simple uh, demo which will have IoT. As I said, I am working in IoT, and this demo is a little bit related to the IoT, whereas we're going to use AWS IoT core and the MQTT protocol on that, so that how IoT devices can communicate their data from the IoT device to the cloud, and also how we can send a message from the cloud infrastructure to a IoT device on the field. And that communication is happening, as I said, in MQTT, and that MQTT stack is developed in Rust. So in this demo, we are going to see how simple it is using Rust. We can do the MQTT communication. That. So let's begin with the AWS um, by understanding what is AWS IoT Core in a brief, and then understanding some MQTT in a brief, and then going through the SDK what we are going to use in this demo. And once to going to the SDK, then how we are going to configure the SDK to do the subscription and publishing of messages to a particular topic, so that the messages can be transferred and received, and how the communication happening, that thing we'll see now. So before that, let's go to AWS. So I'm going to open the AWS here now, which is I already logged in. So let's go here. So there is some network problem. So let's see. It is not coming. I think I hope the network issue is there. Let's do it right now. Let's correct it once. I hope it will connect now. Here it is going. Let's see like how we are going to do. So let's go straight into the AWS IoT core. Let's so here I'm going to explain not in depth, as there is a lot of document about the AWS IoT, so you can go through this. But basically, I'm trying to explain you the small things like which is what is a thing and what is MQTT. These things I'm going to explain, and I'm going to show those things. How can we create here, and how can these things help us in a typical infrastructure. So as I said, AWS IoT. So basically in a IoT device, there is a where we can do means we can deploy the IoT sensors at a field, and the sensors will generate some data, and there will be some actuators on the field, so that the data has to be sent to the cloud, so that the proper control and analysis and decision making of the IoT devices, which can help us in developing a business and controlling infrastructure, can be done. So for that, we need this cloud and the device communication, which is very important. And for that, the AWS has created this AWS IoT, which is very helpful. And on top of this, this uses a MQTT protocol, which is a lightweight protocol which can the device can communicate with the cloud, and as well as the cloud can send messages to the devices in a multiple. Like if there are multiple devices, the cloud can send the device message to the all the devices. So this is, and also the data which is coming from the sensors can be useful to take decisions and create analytics and control to create a digital footprint of a company or a infrastructure. And there are multiple services are available on IoT. As your use case, you can use those services. And I'm not going to those services because this whatever the video stream you are doing today is basically focusing on how to use an IoT core and how to do the communication using the MQTT in a simple way. And also the main focus is on how to use the Rust to do this and how simple it is using Rust it is. So that thing I want to show it. So it will be like not going in deep into why we need IoT, this thing, and what is the details of MQTT. If you come to the MQTT, all this stuff, we're not going in detail. But like for example, MQTT, I will give a brief introduction as it is protocol which is useful like a public subscriber. If someone publishes a topic, like if there is a IoT cloud infrastructure which is going to send a message to all the IoT devices for getting some firmware update, for example, some message like means a unique message to all the devices at a one time, then the cloud infrastructure can send a message to one topic, and where all the IoT, whichever the IoT device is subscribed to the topic, will receive the message instantaneously by using this AWS infrastructure. So that is the thing. Let's go, and in this so we'll see like how it is by using Rust, how we are going to do that. Okay, let's see this some of the things here. You can see that connect one device, this is a device. So if you want to do with simple Python example, you can directly go through this example and you can figure it out. You can, it is very straightforward, and you can download all the stuff and you can run the application, and it will simply will connect to the cloud, IoT cloud, and there will be communication will happens very straightforward. Like MQTT messages will be exchanged between the cloud and the device. And this is MQTT test client is useful to send the subscribe to a topic. It is a common. So if you want to test a specific topic, you can mention here and you can subscribe so that the messages coming on the topic from any device, whether that is IoT device or any remote IoT device, will be displayed here as we are subscribed to the topic. And publish to the topic is like if you want to publish to a specific topic, you can mention that topic name and then you can publish. So when you publish that, whoever the device, IoT device is subscribed to the topic will receive the message. That demo we are going to see this, and this is we are using as a test client for our or we can use this as a test. How to use this, I'm going to show that. And now this is like and as it is a basic stuff, we are not going through the automatic automating the things like creating thing, all this stuff, like just in registration, all this stuff. I felt that is can be an another part of this. We can make a part two of it. So I left that one. This here I'm going to show you simply how can you create a simple IoT thing and put those credentials into the IoT thing and try to communicate using the Rust client software to publish the message and also the subscribe to a message and receive it back. So that is the main thing we are going to do today. And now, what is the client software we are going to use? That thing I'm going to show on GitHub, and that will be see that. So AWS IoT SDK. This is the GitHub link we are going to use to do the AWS IoT thing, like to publish and subscribe to a topic, so that we'll receive the messages on the client side, client, and also we going to send messages to the cloud. So that thing we are going to see using this MQTT test. As I earlier mentioned, the communication is using MQTT. Okay, this is very simple and straightforward, and there is going very simple here. Like I just want to show like Rust, how can you use and how simple it is to do the communication between the cloud and the client using Rust. As the code is very efficient, and it is like memory efficient, it can be, and also their memory safe, as it the compiler provided by default, it is memory safe. So keeping in all this in mind, and I'm going walk you through the project, how it is structured. So these things we're going to do that. So before that, so before using this IoT SDK, I'm going to create a thing here. And so let's, thing is nothing but in a digital, let's say you are a digital print of an IoT device which you are going to create. So uh, so let's create a thing, simple thing here. So already there are some things here available, and these are like one thing related data, you can put it into a separate like if you want to use a thing, you can put that certificates what we get when you create a thing into that particular device, so that the device will act as a registered, means it will make sure that certificates will make sure that it is a registered and trusted IoT device, so that it can communicate with to the AWS IoT core. Yes, we have to trust, like all other, there will be multiple IoT devices. Anyone cannot communicate with the IoT infrastructure what we created. So restrict that, and to make it secure and make it authentic, we're creating these certificates. And this is like what we are doing is like manually I'm creating it. It is a cumbersome job if you have multiple devices, and there is like just in time registration, there is a automatic process for that. But this, as this, that is I'm going to explain in a different video, but this is basically focusing on how to create a thing. We're creating this thing manually so that people can understand easily like how it is going to work. And after that we are going to do the automation thing in the on top of this in the next video. So let's do the manually how we are going to create. So here there is a create thing. Let's go straight forward here, and we are creating a single thing, not multiple things we are going to create. So let's go to next. Let's give a name on this, as we have already IoT. I'm going to give IoT thing as I have one, two. Let's create third one here, and no shadow where I'm going to create, and I keep all the other things default. I'm going to the next page, and auto generate a certificate recommended, and these are the certificate which will authenticate the device, and it will make sure that the security of the communication with the device and the cloud are proper, and no other thing is coming into and sending false data into the cloud. So that is make sure by using these keys. So let's go there. And this is the policy I've created, and this policy is like general policy where the device, means it is very minimal policy. And when you have if you're considering uh, security of the device, so you have to take care of this policy thing. So for now I'm using that already, which policy I made earlier, and the same policy I'm going to use, which is very basic, and there is no, and not take care much like much security aspects into this. But if I'm going to a real project, then I'm going definitely going to this project very seriously. I'm going to take this policy very serious, and I'm to um, the policy I have to create it very secure and specific to the device I will create. And this can be automated in the just-in-time registration process, which is there, which I'm going to make in the next video. So let's go create a thing now. So these are the certificates. You can see that device certificate, and we need all these certificates on our the device, on the device which is going to act as a IoT thing. So like if suppose you have a IoT device, and the device has to send messages to the IoT core which we created on the AWS IoT core. So then that device should have these all certificates so that it can communicate with the AWS IoT core. Otherwise, it will not be able to communicate with this AWS IoT core. I will see if there are any other things already there. I mean, like, so okay, there is no certificates are available before, so I can directly download these certificates, and I'm going to use this these things, and I'm going to save it. Okay, I'm going to download these things also. Roots here, these things. So let us done this. Like I have downloaded, these are the things. Like this is a public key and private key, and this is a certificate which are useful in authenticating the device that and also to whom it is communicating. That authentication means like as a IoT device cannot communicate with all the untrusted things and share the data. So to make sure that it is communicating to the proper this one, and also from the cloud side we have to make sure that the proper devices only communicating. So for that these certificates we are using. So this is the part of that authentication, trust creation, and security creation process. Okay, I hope that you understand that. If you have any doubts, you can ask in this, or you can publish that thing, and you can ask any questions if we have any. So we have created the thing, and we have the thing related certificates here. Let's go and copy these things from here to a separate project. PEM certificate PEM, public key, private key. My second instance, no, that is not needed. And these are the things we need. Copy these things, copy and start. Copy this, and I've already created a separate folder. Let's paste this here, and I need one more root certificate, and this can also be a root CA. This file, and this is a root CA. Let's do this as a rename 1 or 3. I think 3 we name it as rename root CA. So let's have this for these all files here. Let's save this as. So I'm not changing any names here now. Right now, let's see that in the later part we'll do that. Now I'm going to clone this repo, which is going to I'm going to use that, and I will explain what are the things in this repo. So before that, I'm going to clone this git cl1 clone and paste it here, and cloning that repo here. So the repo I'm going to open in VS Code this repo code dot slash. So let's to go to this what is the readme file, and it is there how what are the code details are there in this, like how to run program, all this stuff here. And there is a cargo.toml, there is a dependencies are available on this here. So basically the dependencies we can use these things, or we can use the AWS MQTT all these things, like as you see there is like a um, Tokyo, which is a runtime we are going to use, which will help in async programming, which do the async functions and run them asynchronously. If you want to run multiple tasks, we are going to use this. And MQTT bytes Saturday for parsing, and MQTT for MQTT communication. We are using this MQTT library, and this is these are the feature flags we are using, and also we are including the different files into the project. Like these are the files which are present. So to include these files, we are doing this like this, so that it will be included into the main program. Like this program is the main program where we can have all these things. So here is the actual application, and let's do this is the application which is like we're trying to get the JSON here, JSON format, and also MQTT. We're getting all this stuff here from here, and we're getting the STD error in this. And this is the code. And when it comes to into the code, this is the Tokyo main we are created here, and this is the means like the async runtime we are creating with this main. And there is a return type for this main function, which is a dyn errors, and this is the instance for the IoT settings we are creating by using the new, where we have to give the certificates whatever we had downloaded before, those certificates and their paths we have to give here, so that the IoT can communicate means if the system, but this is the local system. As we are running this program in this system will act as a IoT device for right now. It is not a IoT device, but this system will act as an IoT device. For example, assume that it is a act as an IoT device. But basically, we're focusing on the communication, how it is happening, and how the IoT is IoT core is connecting to the IoT device. Like basically, it will be like if the code is same, we can run on a Raspberry Pi. It will be the working will be same. So here we're trying to create a new, already we created, and using that new thing, the settings we are passing here, and we are trying to get an IoT core client and a event loop, so that the event will be live, so that messages can be received on live. So the IoT event client will be useful for subscribing to a topic and also publish messages on the topic. So here IoT client subscribe. This is the topic name which we have to provide as a string. So here we will change the topic name, and also this similarly whatever the topic we are publishing, for the same subscribe, for the same topic we are going to publish, so that it will be act as an loop back, like how we'll do a loop back in UART setting, like that loop back it will happen here. So that thing, and also we'll see like we'll do separately that subscription and publishing thing in a separate way, and we're going to see that in a later part. And here we are creating two receivers, as we have to receive when there is a message coming from the cloud to the device. So for that purpose, we are creating here two receivers. In case we need at least one receiver is enough. But in here, in this case, we are using two receivers. But we're trying to remove one receiver, and we'll check whether it is working or not. And here this Tokyo runtime, which is like Tokyo, which is spawning all the spawn means we have created all this means all the futures it will return, and these futures are like going to run in the simultaneously using this Tokyo join thing, where the all the functions will run one after other. It's like it will create multiple like async programming, whereas it will run the applications in a asynchronous way. Like this is one function, this is one function, and also this is one function. All these functions will run one after other in a asynchronous fashion. So for that we are using this Tokyo join. Okay, so that is the thing. So let's do that. um, let's copy the certificates Let's before that let's build this. It will um, so before that I'm going to build this cargo build. mm, an example pub sub. Yeah, it's successfully built. But as you said, we need the certificates, proper certificates here. Let's create the. This is the what you call the ID. ID is like a unique ID we have to provide so that no two devices, IoT device should have the same ID. So for that, I'm creating a random that whatever we created there IoT thing instead of a random. We can create a random generator something to keep it unique for this specific device. So I'm creating this. Then we need a certificate. CA root CA we need this. For that I'm going to use this certificate. Any one of these. I'm going to use this root 3 path. I'm going to copy. So let's do one thing. I'm going to close this thing, and again I'm going to open here data so that it will be easy for me to copy the path into the code. So let's do that. Example core, and I'm going to copy this CA3 copy path and put that here. And now and say certificate certificate, I'm going to copy this path. Amazon roots here, I've kept that. Now I'm going to copy this here certificate. So that is certificate. And now going to private key, I need this. So I'm going to copy the private key path. Here you have to keep the private key path. Paste. And the endpoint we have to put. So I think we have to put a different endpoint here. So for that I'm going to already existing which I'm using previously, that thing I'm going to check. So I'm going to that folder. This is an example is there. So I'm going to open this, and this I'm going to check the endpoint from this. I'm going to copy this endpoint where my IoT thing is located, so that it will can go straight for to that point and communicate with the endpoint. So I'm going to paste this one here, and now so that is done. And now we're going to run the example now. So now we done that everything as we have to do. So let's move into the AWS folder. I'm going to run cargo. This is the command we have to use to run the example which is present in the SDK example pubsub. Cannot find new mean. Sorry, that name is wrong. Cargo. Put valid. I invalid peer certificate. So there is a problem with the certificates here. Let's do something here. So I want to copy one more thing from here. So that is the root CA certificate. I'm going to copy this. Maybe this is a thing. Actually, they will generate that generally, but here I'm getting the error. So let's try this one here. Check whether that is the problem. The problem we're getting here is invalid peer certificate unpunished issuer. So let's do that. What I'm going to do is paste this here. So now the paste is not working. Then I'm going to put that. Sorry. Here I'm going to pen this and put this here. And take this path now. The path I have here is the path and put in place of here. Control V. So that's it. Let's do now run again. Yeah. So now you see that the got event on receive, like this is the receiver. So it's got successfully pinging and receiving, waiting for the response. And this is ping is like is a message which will tell that there is a connection is established and the response is exchanging between the IoT and the local system which is here present. So right now we are have different topics, like we are subscribing to one topic and publishing the data to another topic. So there is like a difference in the topics, so that's why we are not able to see the things properly. We're not receiving any message at all. Let's stop this and change the topic name to 1 2 3 4 6 5, and the same topic I'm going to copy from here and paste it here. Both are now same. Let's do the thing now. Whatever the message here, we'll put like hello everyone. Let's see that how the looping will work now. I hope that looping will work. So received hello everyone on topic 1 2 3 4 5. So it is like the code is like only one time. We have published that and it is received on one time. So it's like that. So let's do it. Like here, here the handler we have, and we are publishing the message only one time. So that's why receiving the message here one time. Let's try to publish from here that IoT core on the topic what we created. So let's publish a message here to the topic test 1 2 3 4 5. Publish it. So here we have received the message. So the topic we subscribed here published on this topic. So this code which is running on the local system is subscribed to this topic as 1 2 3 4 5 test. So it is also receiving the same thing here. So straightforward. So similar way, the publishing thing here, there is only one time here the code. So it's publishing only one time. So let's do one thing here to test that the publishing thing is publishing to the cloud. So let's comment out other parts and only we'll keep the publisher part separate. Let's do this thing. So as we see that it is clear, right? The receiver is working fine and the publisher also working fine, because the message whatever we sent here, hello everyone, is a published message, and it came back as a received message here. The publishing message, whether the publishing is working or not, we have to check. For that purpose, we are going to change this code in a little bit so that it will be very clear. So we don't need this stuff. Let's comment out this for publisher, and also we don't need this stuff, and this is also part of a receiver. So let's comment out this thread also. And now let's come to this part. And this part is also this is like a listener, which is helpful in maintaining a constant connection with the AWS-IOT. And these two things are we are not using. Let's delete these things. So that will be fine. And that will be fine. And also we don't need this. Let's save this and go to this tab. And these receivers also we are not using. So let's comment out this. Now we have all this stuff and listener. Now we have a one publisher. So publisher also subscriber is not needed, as we are not trying to subscribe, receive the messages. Only we are trying to publish the message to the AWS IoT. So now this is the thing. So let's do that, and let's use this part to create a loop of that publishing, so that continuously it will publish on the topic, and also we'll create a simple delay here. Let's do that also. So now going to do this, take this part, this publisher, copy this and put it inside this code, and uncomment this first, and remove this part here. Okay, now copying this part, and there is some issue here. Let's remove this out. Okay, and we need one small thing here. So there is a time, we need time related stuff. For that I have already a code, so that I'm going to there, trying to copy that stuff. Okay, I will, otherwise I will do from here. There is one more code I have. So I will going to, you just save and go there. Simply I'm going here, and I'm going to copy this part here. There is that part, receiver part is there. So this is not this one, sorry. Going to see other thing, hypertext. Delay thing, it's not there. So okay, let's do it that way. We'll check whether it is working or not. So it is a simple demo, no issues. So straight go into this video IoT AWS SDK. So directly we're going to publish. It will be very fast. It is publishing. So let's see whether it is working or not. Maybe just fast of this may create, like we are publishing very fast. Whether the receiver is able to receive the messages or not, we're going to see that. So that we're going to do that. So now, and the same thing, like I'm going to change this thread name pub1, and we have to spawn on this. So that's why I'm keeping this pub1 here. Let's say this. Now run this, and we're going to test this. Subscribe to the topic, test 345. if everything goes right, the messages whatever we are publishing, hello everyone, has to come here. So then we are sure that it is publishing successfully. Yeah, you can see here the messages are coming here. Okay, yeah, you can see that the messages are publishing here, and as a message is coming back here from the, we're publishing from the device and the messages are coming here. So, this is working, but I hope that this is got stuck because we're sending the messages very fast. Let's stop this. And now as seen that, so now it stopped. So we stop that. We're going to try to reload this. 1 second. And this is the short introduction of the AWS-IOT and how we are going to use Rust. Simply, how we can create the MQTT client server communication, and how can you publish to a topic, and how can you subscribe and get the message from the topic when someone is published on the topic. So that is the simple introduction and simple demo. Thank you everyone, and hope that I'll try to create a second part and publish that one, which will help in creating automating the thing of creating process of creating thing, which is just in time registration. I will try to make an detailed view, and this is a basic one. If I have any queries and any questions you have, you can ping me. Thank you. Have a great weekend.